So as we saw in the D block, we go n minus 1. And the reason they're in this order is because of the energy orders, right? Electrons fill from lowest energy to highest energy. So what we're saying is that the 4s orbital is actually lower in energy than the 3d orbital. So the question is, why are ns orbitals, so example 4s orbitals, lower in energy than n minus 1d orbitals? So in this case is 3d orbitals, right? Why is this occurring? As n increases, shouldn't energy increase? So shouldn't 4s be above 3d? And so experimentally, it's not. So we know it's not true. So we have to adjust our model. And quantum mechanics actually predicts this happening. And the reason this happens is because of something known as penetration. Penetration, right? So if we think about our probability diagrams for our high n orbitals, I have this picture right here. Remember, they all look like spheres. And as we get to higher values, like 3s, they look like spheres inside of kind of spheres, right? So even though most of the time the electron is out here, it can actually penetrate these orbitals and get very close to the nucleus. So in this kind of, you see the 3s right there, you see there's still a chance that this electron can be right next to the nucleus. And so this is known as penetration, because it's kind of penetrating the other orbitals to get to the nucleus. So what happens is high n s orbitals still spend time close to the nucleus. And remember, we said the closer we are to the nucleus, the lower the energy we are, right? So they penetrate. Let's take a look at when we compare that to a d orbital. So here's the 4s orbital in terms of its probability, where it probably is in relation to how far away from the nucleus. And so you can see the 4s and the 3d in this diagram, right? There's 3d, there's 4s, and you can see it's pointing to this zone right here. You see how the 4s has a possibility of being very close to the nucleus while the 3d does not. And so that's known as penetration, right? So because of penetration, the 4s is lower in energy than the 3d. Than the 3d orbital. But again, if we just use our periodic table, it's not an issue. Just read the periodic table like a book, left to right, line by line, and then remember in D block, you're n minus 1.